Hello guys, welcome back to the channel again. Today we will solve the 16th question of June lead code challenge. So the question is validate IP address. We have given an IP address, it can be IPv4 and IPv6 also, and we have to check that this IP address is correct or not. If it is correct, then I have to return which version it is IPv4 or IPv6, and if it is not IPv4 and also not IPv6, then I have to return neither. So we will do this using divide and conquer. So first of all, we will discuss how we will do that. Now we will discuss first for this IPv4 and then we will discuss for IPv6. So first of all, we will take a string. This is as a string we will get as an input. So after getting the string as an input, now what we will do, we will first split it into 4 parts according to this 0 or this dot. So what will be our parts? Part 1 will be 172. Part 2 will be 16. Part 3 will be 25. And part 4 will be 1. Sorry, part 3 will be 154. So these 4 parts are there. Now what we have to do? Now we have to check that each part have valid number or not. So for IPv4 we have only integer numbers. So integer number can be in range 0 to 255. So the number 256 can't exist in IPv. So IPv4 we have some limitations. I have told you the limitation. Now we will check for every part. First of all, we will check that this value exists between 0 to 255. So this is true. Now we will check for this and this and this. So after checking all, we will submit that this value is IPv4. So what we will do for IPv4, we will split it from dots and then we will check that the value exists from 0 to 255 or not. If the condition becomes true, then we will check for next one, and if 4 times this condition becomes true, then we will return true or return IPv4. So after this we have completed IPv4. Now we will discuss IPv6. Now first of all, we will check that what is the number or what is the highest number we can achieve in IPv4. So we can insert F. This is the highest value in IPv4. So what it will represent? A will represent 10, B will represent 11, C will represent 12, D will represent 13, E will represent 14, and F will represent 15. So these 6 representations are there with us, and the usual numbers are also there in 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 numbers and 0. So this 10 and this 6. So 16 number. So 16 number can exist at every place, and the length of every digit or the every subpart can be 4. So the range is 0 to F. So this is the highest range in which this number can exist. So how we will check for this? So again, first of all, we will split it from double dots or from this part, and we will make 8 parts out of it. 1, 2, 3, 4, 5, 6, 7, 8. So if parts are less than 8, then we will return false, and if parts are greater than 8, then also we will return false. So exactly for 8 parts only we will check. Similarly in IPv4 also we will check for 4 only. If it is less than 3 or equals to 3, then we will return false, and if it is greater than 3, then we will check for this condition. If this condition is satisfied, if this condition does not satisfy, then we will return false. So after making the parts, suppose the first part is this. So we will check that if the value should be greater than this, Or first of all, what we will check, each value we will check. If suppose we get this as substring, then we will compare each value with 0. We will compare first thing that it should be greater than 0. If it is, then there is no problem. And second thing, we will compare that it should be less than 9. So if any of this condition becomes true, then we will return true. Or we will check one more condition, that this value should be greater than a or less than f. So the value should be this. Means what we have to check, we have to check two conditions, that the value should be greater than a and less than f, and it should be greater than 0 and less than 9. So these all conditions we have to check for IPv6, and for IPv4 we have to just check one condition, that it should be greater than 0 and less than 255. So first of all, here we have input as IP. Now I have declared two things, CD and CC. CD for IPv4 and CC for IPv6. Now we are checking that how many parts are there, because in IPv4 if we have less than 3 parts, then we will return false, and if the parts are less than 8 for IPv8 or IPv6, we will return false. So first of all, I am checking the parts. So this will increment when our dots come. So for IPv4 we will get 3 dots, and for IPv6 we will get 7 dots. Now we will check that if it is true, then only we will go through this code. Now if it is not true, then we will return. So for 3 we will check for IPv4. So for IPv4 I am calling this function, and for IPv6 we are calling this second function. So we will now see what is function doing. Now first of all, I have pushed back one more dot to the string such that I can compare all the strings, because first part will be terminated by dot comes and second part will be terminated by dot comes. So the last part will be left alone. So for comparing that last part also, I am using this dot. So first of all, I have declare a string 3 in which I will store every indexes or every value if dot not comes. So in this condition, what first of all we are doing, so in first condition never this runs if it is IPv2, or sorry, if it is IPv4, then this condition will never run at first time. So first time this condition will run. Now what here it is checking that the value should be less than 0, sorry, this value should be greater than 0 and less than 9. So this condition is checking here. So if it is not the condition, then we will return the false, and we will, if it is true, then we will return or push back a into t. Now what after this all condition t will be, so suppose we will take this as an example. We will take example as 124.2223.0.60. So we will then take this as an example. Now in our first attempt, what will be t? T will be equals to 1. Now again the loop runs, and now we have 2 at a, so 2 is this condition becomes false, so false will not be returned. Now again 2 will be pushed back. Now again this same loop runs. Now 4 comes. Now what all conditions we will check? If t's length is 0, then we will return false, because the length of t can't be greater than less than 0, or can't be 0. So next condition, what we will check, the length can't be greater than or equals to 4, because maximum number is 255. That's why. Now next condition is that we will compare that the value should be less than or equals to this 256. So we will compare this thing. Now what here we are doing, that the length of this should not be equals to 1. If it is equals to 1, then we should be having t0 index equals to 0. So means t0 index can't be equals to 0. So if it is equals to 0, then we will return false. So what I am trying to say with this last condition, that if the length is equals to 1 and the index is also 0, then we will return false. means if the length is 2, suppose the length is 2 and we have 0, then x equals to 0. So in IP we can't use this 0 1 because this will be false. So we are checking for this condition. We have used this last condition, this last one. Now this will be done for IPv4. What we have done first we have checked for every character that it can't be equals to 0 or 9, or sorry, it can't be greater than 9 or less than 0. So if it is true, then it will return false, and if it is not false, then it will be pushed back into T. So after, at the end, we will append this value into T, and then we will compare these three conditions. If this three condition becomes true, then we will empty the T and we will ready for the next condition. Now if all the 4 indexes are true, then we will, at the end, we will return true. Now we will see for IPv6. So we will take this as an example for IPv6. Now first of all, what we are doing, first of all, here we are again doing the same thing which we have done in IPv4. Here also we are initializing the T. Now here we have first check that if it is not this condition, means if it is any digit, then what we will check the 3 condition which I have told to you, that the number should be less than, or sorry, greater than A and less than F, and it can be capital also. So we are checking for capital also. Now the value should be greater than or equals to 0, and the value should be less than or equals to 9. So if it is true, this condition becomes true, then we will push back A into T, and at the end what T will be there, so we will traverse it. So first time when loop executed, T will be, so A will be 2. So at this condition T equals to 2. Now again the loop runs, 2 equals to 0. Then this condition again becomes true, so 0. Here again 0. So we will again append 0. Then 1. So it will become 1. Now after that what will happen? Now we have T equals to this. Now what will be A equals to this. So we will execute now this thing. Now what we will check first, if the length of this is 0, then it is not possible, because length of 0 is not possible in IPv6. So after this what we will check that the size of this T is greater than or equals to 5, means it can't be greater than 4. So we have written false. And if it is not the case, and if it is in the valid condition, then we will initialize T equals to empty string, because we have completed part 1. So like this we will complete all the 6 parts. Now like this we will complete all the 8 parts. Now if all the 8 parts are true, then we will return true. So after returning true, what will happen? So here I have returned 2. So here I have returned 2. Now what will happen? If the condition is true and this is previously true, so we will return IPv6. In IPv4 also same condition, and if both becomes false, then we will use neither operator to return, and at the end also we will return neither, because if it does not go into this ifs, then we will use this thing. Now what we will do, we will submit the solution and we will check that how much time complexity or memory it is using. So it is very fast. It is just using 4 ms and 62.2 MB of memory it is used, so it is very fast. Thank you guys. For more such content, like, share, comment, and don't forget to subscribe.